Hi everyone. The topic is digital image fundamentals. First, we are going to discuss about elements of visual perception. This diagram shows the simplified diagram of a cross section of a human eye. The structure of the human eye, it contains lens, anterior chamber, ciliary fibers, ciliary body, ciliary muscle, cornea, iris, visual axis, vitreous humor, retina, blind spot, fovea, sclera, choroid, and nerve sheath. These components are really responsible for the visual perception of a human eye. And it shows the rods and cones in retina. It is responsible for visual perception. And here this part between cone and rod is called blind spot, degrees from the visual axis, center of fovea. Here there is no visual in blind spot. The distribution of rods and cones in retina is visualized here. And this shows the image formation in the human eye. This is a graphical representation of the eye looking at a palm tree. A point C is optical center of the lens, and distance from the palm tree and the eye is shown here: 100 meter, 17 millimeter, and 15 meter. This perfectly shows the image formation in the human eye. Here the eye it can see the palm tree, but it can be visualized in opposite and inverse, and finally we'll see as actual. And then we have to analyze the brightness adaptation and discrimination of human eye. Here this wave, it shows the range of subjective brightness sensations showing a particular adaptive level. Here subjective brightness and adaptive ranges are shown here. On this we have a scotopic and photopic visions. These are all main elements of visual perception, and we have a BA for absorption and brightness, and we have also mentioned the scotopic threshold here. And this we have glare limit to limit the visual perception of a human eye. And brightness discrimination, basic experimental setup used to characterize brightness discrimination here. Here we use eye and del eye. Illumination of any peak or intensity of the peak, and del eye, it represents the differentiation in that element. Here we can easily differ the brightness of any two images or any two pictures. And here Weber ratio is one important thing. Typical Weber ratio is a function of intensity. Here this graph is between log I and log